this morning we're going to take a look at how to do a SIK, a Sparkfun Inventors Kit circuit project in the TinkerCAD Circuit Simulator, which is how we're going to do projects for the rest of this semester. So I'm going to get a couple of windows open. Here is our Canvas electrical engineering class. So I'm going to go to modules, and you can see here's the Sparkfun Inventors Kit that we've been working through. So I'm going to do one of the SIK circuits 1 through 6. We'll do the RGB LED. That's a good one. So right here, all of these link out to the Sparkfun site, which has the same information that you had in the booklet in your kit. So this is the experiment guide for Arduino version 3.2. That's the version of the kit we had in class. If you'd like to try one of the more updated versions, I don't have a problem with that. It just won't match what you were doing in class. So as you scroll down, you can see the parts that we will need. For us, these will be virtual parts: a breadboard, a Redboard or Arduino Uno, a RGB LED, some 330 resistors, and jumper wires. That's not a lot of components, so we're going to get those wired up in the TinkerCAD circuits. If we scroll down a little bit more, it has information on how these need to be connected correctly. So for example, the RGB LED, you can see it has 4 wires. This longest wire is the common cathode. So a RGB LED is really kind of 3 LEDs squished into a small space and sharing this common cathode, common ground. So this one is the red, and then it shares this ground wire. This one is the green, it shares this ground wire. Blue shares the ground wire. Aha, just like that. Okay, and then here is a picture of the circuit that we will be creating. Doesn't matter whether you look at the breadboard or the Arduino, they are the same, and we're going to go look at what it looks like in TinkerCAD. So here I have my TinkerCAD window open. That's also linked in Canvas. I'm going to go down to circuits. I'm going to create a new circuit. I am going to rename this one. TinkerCAD does a great job coming up with very creative names for you so that you don't have 20 things called Untitled 1, Untitled 2. But I highly encourage you to name them something that actually reflects the project we'll be doing. So we will be doing SIK version 3.2, the RGB LED. So the first thing I'm going to need is a Arduino Uno board. So if I go over to components and down to Arduino, the very top one right here says breadboard. If I bring that out, just by click to select it, and then take your mouse out and click where you'd like it to land. Okay, so now I have an Arduino board and I have a breadboard. The power and ground are already hooked up. Hopefully this is familiar from last week when you were practicing with making some circuits on a breadboard like we did in class. So now I'm going to wire up this circuit the same way that I would if we were in class. So I'm going to create this circuit in TinkerCAD circuits. So now that we can see both sides, we have the circuit that we will be creating here on the left, and we have our circuit over here on the right, except I need to get it more centered. There we go. Okay, so if we look at this one, it seems like maybe the first thing that we're probably going to need is the RGB LED. So if I come back over here to components, and now I go to all, and I scroll down, you can certainly search in here. LED will bring up everything with an LED. RGB will bring up RGB related things. But you can also, in this case, it's not far down. You can certainly scroll and find the part you wanted. There it is, LED, the RGB kind. So I'm going to click and bring that one in. You can see over here, they kind of put it on one side of the aisle down the middle, and then had resistors going across the aisle and wires going the rest of the way. It's not the only way to do it, but I would like to model off of the example as best I can, so that's what I'm going to do. Okay, so if you kind of zoom in, you can take a look. It's going to automatically jump into a set of holes, so you don't have to worry about like missing and going in between holes. That shouldn't be a problem. So you can just click and it is in place. One of the nice things that TinkerCAD does is if you hover over the ends here, you can tell what each of those is supposed to be doing. There's red, there's the common cathode, blue, and green. Cool. So next up, I'm going to add the resistors. If you zoom in a little bit over here, or if you go down and look at exactly what components they say should have, it is a 330 resistor, so that's 330 ohms. So that's what I'm going to use too. Resistor is right up here at the very top, or you can type in resistor and it'll pull it up. So I need one for the red leg, so red. So it's jumping from this leg through the resistor and onto this 8 row here, and then we will go out from there. But I do not want a 1K resistor. I want a 330 ohm resistor. So this is where you can control how much resistance your resistor is giving. We want a 330 ohm resistor. So that's what we now have. I'm going to do the same thing for the green and blue legs. Change it to a 330 ohm and 330 ohm. Okay, so my resistors are handled now. I have my RGB LED, I have my resistors. So if I look at what's next, we have some jumper wires. So there's this one, this black one is going from the common cathode all the way to the ground rail. I'm going to do that one next. So now if I just kind of click off that resistor, we will be able to have that space back on our screen. If I don't have a component selected, it's automatically going to assume that I want to do wires. So if I click on any hole, it's going to start a wire and another hole, and now I've connected those two, and I can control what color wire I will be using, except I don't actually want that wire. All right, so what I would like is to connect the common cathode, the common ground, to the ground rail. So I'm going to choose one of the dots in this row that's labeled cathode, like this one. And I could go up to this ground here, but I feel that might kind of overlap my LED, so I'm going to take it down to this one right here. And if you remember previously, we saw that that was connected out to our Arduino board right there. Ground, it doesn't matter what color these are, but ground is usually made black for consistency, so I'm going to do that as well. Okay. Next up, we have the red, green, and blue pins that we want to connect on our LED to our board. So you can either zoom in on this right here. You can blow up the picture by clicking on it to make it a little bigger. But it also tells you down here what you want connected where. So they want the red, they want the A2, and that's a label on here, A2, see that red one, oops, that red one is A2, is gonna go over to pin 9. So the red one is going to go to pin 9. So that's what I'm going to do as well. I'm going to hover over this. That's red. It's going to go through the resistor. And then I'll say take it from here to pin 9. As you hover over these, a little pop-up tells you what pin you're looking at. So there's digital 9. But I know that it's supposed to be red, so I might as well make it red and help remember later. So for them, the next one, let's see, want to get back out of my picture. There we go. The next one, pin 10, is supposed to be our green. So green to pin 10. So for us, this end one is actually green. So I'm going to take that one and go to pin 10. And that one is already green, so I'm good. And then the last one, if we look back at the Sparkfun site, pin 11 is what's connecting the blue, I believe. Yes, that looks right. Blue for us is here, pin 11. And I will make it blue, blue, just so we remember. Okay. So we have wired up the RGB LED circuit from the Sparkfun Inventor kit project. I believe this is project 3. Excellent. But right now, it wouldn't really do anything. If I were to hit start simulation, not really a lot going on. This is not a very exciting circuit because what we're missing is code. When you bring in an Arduino board, it automatically adds this code screen so that you will be able to write code for your Arduino. By default, it has it in blocks. I'd like you to go ahead and change that to text. It says, are you sure? Yes, we're sure. The reason we're changing it to text is every single one of our examples is done in text, not blocks. And I'm going to expect you to turn in text, not blocks. If you want to find some tutorials that show you how to do blocks, that's okay. But I'm going to expect you to turn in the text. So it's important to get used to that. So this is the code that's automatically generated when you bring in an Arduino board. I'm going to go ahead and delete all of that. So for the actual just following the example, what we would do next is come down a little bit more. And here is the code that matches this circuit. So if I hit copy code, it'll say copied. If I come back to back to TinkerCAD and Control V or right click and paste, that is all the code on this example project. Now it looks really, really long, but like more than half of that is explanation and text. So please don't feel intimidated by the length of those. Okay, so if we go back to the Sparkfun page, you can certainly keep going down. It has some great notes in here about code explanations, about how exactly it's working, and some notes on real-world applications. Those are all really useful, but I'm going to leave them aside for now so I can show you more about TinkerCAD. Yes, so the pages are linked on Canvas. You got it. I can show you that again at the end. All right, so for now, let's see how we're doing. So I now have code. I have all of my parts set up. So before I talk too much more about the code, I'm just going to start the simulation and we're going to see what happens. If we have built it correctly and copied everything into the code section correctly, we should see some stuff happen to the RGB LED. So I'm going to hit start simulation right up here. Hey, red, green, blue, yellow, teal, pinkish, white. And now it's doing kind of a fade thing. Here, I'll zoom in so you can see it a little better. Yay! Okay, so this is good news. We wired it up correctly, and now it's repeating. So now I want to look at the code together a little bit. In TinkerCAD, comments show up in this kind of orange color. So all of this section, whoosh, all the way down to here, all of this is comments. These are really helpful. They do things like explain how the hardware is connected, how we connect to a common pin in ground. These are explanations of how the code is working. All of these things are really, really useful, and I highly encourage you to actually read them. It will only be of limited use to you to just copy the circuit exactly as it is listed and not do anything yourself, right? That will maybe help you with your wiring, but that really won't help you with your coding, and that really won't help you with creating your own projects, which is what we're going to expect out of this. So if we go back to Canvas briefly, what I've added to the SIK experiments is something that you should try and figure out. For example, what values will get you purple? How about orange? So let's go see if we can't figure out how to get purple and orange for our light. All right, right up here at the top, you will see that it starts with assigning the red, green, and blue pins. If you remember, that is how we plugged into the board. Here's red pin number 9, red pin number 9, green pin number 10, green pin number 10, blue pin number 11, blue pin number 11. That's how your program and your board know where you have connected your components. Display time, they have set this up as a variable in case they want to use it later. I believe in this case it's being used to time that fade that we're watching right now. Excuse me. Next is the setup section. The setup section is, this is where your board is really finding out which pins you will be using for what. In our case, we're using the ones that we designated, red pin, green pin, and blue pin as outputs. So ways to give information, sending a signal out from the board as opposed to a sensor, which would be an input, meaning we're taking in information from the outside world. Next up in this sketch, this is another explanation about how the loop is going to run, and they're showing two different ways to use the RGB LED. First, main colors, that's where it flashes, those main red, green, blue like it's doing right now, yellow, teal, magenta, white. Okay, those are the main colors. And then it goes in and does a show spectrum. Both of these are just functions, just other little bits of program, and they are farther down. Here is main colors. Okay, so how does this work? It turns on, so first it turns all of the LEDs off. You can see that. It sets digital right of each pin to low, which means off. This one makes red by turning the red pin on, the green pin off, and the blue pin off. It waits for 1 second and turns just the green on by turning off the red, on the green, off the blue, etc. So it goes through all the colors like that. Then we get a whole bunch more explanation down here on how show spectrum works. Here's show spectrum. So I encourage you to read through that. I'm not going to go through all of it right now. I am going to show you something different. So in our loop section, I'm actually going to turn off by commenting out. Ooh, I can't do that while it's simulating, sorry. Stop simulation. I'm going to comment out main colors and show spectrum, and instead get myself a little room up here and show how we might test individual colors. So we could, for example, do a digital write on the red pin to high. So this is no longer a very interesting program. Literally, the only thing that's going to happen is it's going to turn on the red pin, and we can watch that. There we go, it's red. That's the whole program. Very exciting. You can just watch it be red. Okay, but that means our coding worked. That's excellent. Now, instead of digital, I'm going to use analog right on the red pin. And instead of high and low, analog takes 0 to 255. So I'm going to try something in between. Let's try 150. So you can think for a minute before I hit the start simulation button about what's going to happen. So what's going to happen is it is going to send a signal out the red pin, but instead of all of the available, it's only going to send 150. So let's watch what happens. So it's still red, just not quite as bright red as it was before. So I could take this idea and turn on all of them halfway. Okay, so in this case, I have red at 150, green at 150, blue at 150. It makes kind of whitish, right? Because when we combine all of the colors, we get white. So I'm going to hit stop. Let's go, so let's see, we wanted to make a purple color, right? Purple. So I might not know off the top of my head how to get purple from a combination of red, green, and blue, but fortunately the web can help us out if you just search color picker. And let's go see if we can find a good purple. Ooh, that's a nice purple. It's a very pretty purple color. So if you look down here at RGB, that's red, green, blue, just like our LED, and it is advising 162, 50, 168. So let's go try that and see what happens. 162, 50, 168. So if we have chosen correctly, hopefully this is going to look kind of purple. Let's take a look. That's a pretty good purple. Maybe a little lighter than I expected, but not bad at all. Okay, so what was the other color we were looking for? Orange. Let's go see if we can also make a nice orange. It's a little dark. That's a nice orange. Okay, so this is recommending 242, 153, 10. So I'm going to stop the simulation. 242, no, I don't remember. 153, and 10. Not bad. Very orangey. So I could answer those questions now, saying exactly what values would give me purple and orange. Okay, so this is what I would like you guys to do as your kind of practice for your own project. You should be going through the SIK circuits and creating them yourself in TinkerCAD, in the circuit simulator. You should be pasting the code in, running the simulation to make sure it works. You should be actually reading through the notes and the code to make sure you understand how it works, because when it comes time to make your own project, it's okay to start with someone else's as a template, but I do expect you to do some of your own coding and circuit design. And you won't want it to be exactly like an example, because your circuit will have a different intended purpose. Once you feel like you have a good grasp on what's going on there, you can go take a look at Arduino Project 1.